All right, guys, today's lesson is the start of Module 2. We're going to break this first lesson into parts, but we're going to work with angles and congruence. A lot of vocabulary to start. So we have to know what array is. Array starts at an endpoint and then goes forever in one direction. Okay. And so this is ray AB or ray AC. It does not matter which way you name it. Either point besides the endpoint, it had to start as A because that's where the endpoint is. Right? This little symbol with one arrow above the letters means ray, so that stands for ray. If this same thing went the other direction, I would still have to name it this same way because that's where the endpoint is. So it would still be ray AB. Opposite rays, this is not as important here. The big thing is you need to know that they equal 180 degrees. Basically, it's saying a straight line equals 180 degrees. So that's the important thing to get into your notes here. Opposite rays just means that, like, if we start here at B, BA and BC go in opposite directions, and so they form a line. But really, let's take away from this today that a straight line has 180 degrees in it. And then an angle is a pair of rays with a common endpoint. So you have this endpoint that we call a vertex, the common endpoint vertex. So it's the vertex of the angle. And then the rays are the sides of the angle. Now, how do I name an angle? Well, first, this little angle sign there stands for angle. All right? And so that's how you would denote that it's an angle. Now, most of the time we name an angle, we're going to use 3 letters. It doesn't matter whether I call it DAB or BAD, or I could use C, DAC, or CAD. It does, however, very, very much matter that A, the vertex, is the middle letter. The vertex always has to be the middle letter. So you can't call this like angle ABC. Calling it angle A is a little bit interesting. You can, in this case, call it angle A, but if we have something where there's 2 angles, there's angle 1 over here and angle 2 over here, and this is A, you can't call them both angle A. So therefore, you would have to either have other letters to use to name it, using 3 letters, or you can put a number in. So like I could come down here and write a number 4 down here and then call that angle 4. But most commonly, you're going to have to get used to the 3 letters with the vertex being the middle letter. Hopefully pretty easy for you. You got to know the difference between interior and exterior. So they're going to talk about things that are on the interior of an angle. Interior means on the inside. So the angle opens up to this direction. Right? So these points G, F, and H are all on the interior. Okay. And so that makes these points now I, J, and K on the exterior. Points D, B, and C, or maybe you can say D, A, B, and C, are on the angle. So inside and outside the angle, exterior and interior. All right, first example, name all the angles that have D as a vertex. Well, there's a whole lot. D is right here. So I could talk about FDE. Or I could talk about BDE. Now, those 2 are the same, so it doesn't matter which way you name it. They're talking about the same angle, FDE and BDE. So I don't have to name it both ways, but I have to name that angle, angle FDE. And then I have this angle, EDG or GDE. Doesn't matter which way, as long as D is the middle letter here, so EDG. And then angle, what is the next one with D as a midpoint? D is the vertex, rather. GDH. GDH would work. All right. Also, HDC would work. And so let's get those 2 down. GDH and angle HDC. Now we did GDH and HDC. We could also do the whole combined of those 2, angle GDC. Angle GDC. And then let's keep going here. Next I see angle CDB or CDF or FDC. All right, so naming that one of those, CDF, is how I'll call it. All right. And so that was this whole thing. Now I also have FDH. I haven't done that one yet. I've done this 90-degree-ish looking one, but I haven't done FDH, which is obtuse. It's bigger than 90. And so angle FDH. Right? And so I have all of those, plus I have angles 6, angle 7, angle 8, angle 9, angle 10. Now, really, those are some of the same angles we've already named, so I don't have to have them both, all right? But I'm just showing you can name those angles that way as well. Name the sides of angle 2. Well, first off, where is angle 2? Angle 2 is right here, and so what are the sides of it? Angle 2 is formed like this, right? And so ray BA is this ray that's starting right here and going this way. And then we want to start right there and go this way. And so I could call that one ray BD or BG. Wouldn't matter which way you write it. Those are the sides of angle 2. Next part of this example says name a point in the interior of angle FDE. Well, first let's look at where the heck is angle FDE. FDE is right here. And so the only point on the inside of that angle is point A. So A is the point on the interior of angle FDE. All right, you try. The part A here. Take a second. Find angle 4. Angle 4 right here. What letter point is the vertex of angle 4? Hopefully you knew that it was U. Now let's go here. We're down here. We're talking about angle 3. Angle 3 is right here. The sides of angle 3 are XW and XU. And so this one right here should go there for the sides of angle 3. Congruent. Hopefully you remember congruent. Now I could also write this as congruent angles. So you got to get used to the abbreviations. All right, congruent angles. Congruent means same size and shape. So congruent angles have the same measure. Right? Also very important down here, if I put the same number of arc marks inside of it. So here they both have 2 arc marks inside of it, then that means they're congruent to each other. So those little marks, just like when we had a segment and another segment, I knew they were congruent by the tick marks. I know the angles are congruent by these arc marks. I will call them tick marks too, to be honest, sometimes. Bisector. Bisect means split into 2 equal parts. All right, so it's the same thing. 2 congruent parts means if it tells me ray TR bisects angle QTS, then I know this ray bisected this whole angle QTS into 2 equal smaller angles. And that's what we're going to use here. And so it says ray BD bisects angle AB. Angle AB, what am I talking about? Angle ABE is that whole angle. And so bisects means it splits into equal parts. So this part and this part are equal. All right. Now let's keep reading. If angle ABD is 4x plus 14, so 4x plus 14 goes here. And angle DBE is 8x minus 32. Well, they're marked as congruent. So they're congruent means 2 equal parts, or congruent means that they can set these as the same measure, right? And so 4x plus 14 equals 8x minus 32. I like to move my x's together first, so I'm going to minus 4x to both sides. I get 14 equals 4x minus 32. I'm going to add 32 over. I'm going to come up here to continue working. I get 46 equals 4x. I divide by 4. I get x equals 11.5. And now it wants me to find DBE. The measure of angle DBE equals 8x minus 32. And I plug the 11.5 in. 8 times 11.5 is 92. Minus 32 is 60 degrees. This one's a kind of a strange example, right? Again, it says bisect. What does bisect mean? All right, so KN bisects angle LKM, so it splits it into two equal parts. So this part here and this part here are equal. And it says the whole thing, LKM, the whole thing, from here to here, the whole thing is 7x minus 5. And then it says NKM here is 3x plus 9. And so if this one is 3x plus 9, I know this one is 3x plus 9. I said it's a strange example. And so I'm going to add those together. I'm going to say it's 6x plus 18 equals 7x minus 5. I minus the 6x over. I add the 5 over. Now for the measure of LKM, I have to plug in. LKM was right here. 7 times 23 minus 5 is 161 minus 5 is 156. All right, that's the halfway point of the lesson. To page 71, 1 through 9, you must show work on 5 through 9.